Hi, this is Dr. Y.S. Rao. In the previous session, we have discussed about how to use the microcontrollers for interfacing LEDs. And we also discussed about the mathematical models to generate various signals. And we also discussed about the modulation techniques. So since LED is a output device, where the data is flowing from the controller to the outside world. In the program, we have configured the pin mode as a output. In this session, we will discuss about the microcontroller pins as a input mode. That means the data will flow from the outside world to inside the CPU, where you can store in the internal memory of the CPU. So if you look at the controller, particularly the controller which we are using in this internship program, EDU-Robo, we have used ESP-32, which is a 30-pin controller. Other than pin number 1, 14, 15, 16, 17, all other pins which are shown in the orange color, right, like GPIO 36, 39, 34 to GPIO 23, which is pin number 30. They are called general purpose input output lines. As the name says, general purpose input output lines. So in the previous session, we have configured these pins, these mini pins, you can configure as output. However, in today's session, we will configure these pins as a input mode. So what is the syntax to configure the pin in input mode using embedded C compiler, particularly using Arduino as a compiler? Whenever you want to know the syntax or the keywords specifically related to the hardware, you should refer the Arduino compiler reference manual. Otherwise, 80% of the syntax is same as any other N6C, whatever we use in a computer. So if you refer the reference manual of the Arduino compiler, if you look for pin mode, in today's session, this pin mode, the syntax is pin mode in bracket number of the pin, comma, mode. What could be the mode? The mode could be input, output, or input pull-up resistor. Alright. So there are three possibilities of mentioning the mode. And what do you mean by pin? Pin means the number. The number means, like you can see, 36, 39, 34, 35. Nothing but GPIO number. Controller to controller, maybe if you use some other controller, the number could be different. As far as ESP32 is concerned, they have specified the numbers. So some of the ESP32s are even having more pins. So naturally, you should mention the same pin which is recognized by the compiler. So for example, if you are interested in pin number 2, then you say 36. So that means pin mode bracket 36 comma. Now mode means in today's session it could be input in capital letters, not output. In the previous session we configured as output. What do you mean by input pull up? Input pull up means that particular pin, what is the amount of current you would like to flow from the supply line, that is a pull up resistor. If you refer the digital pins, more information you will get. So how would you write a program? The program is as follows: void setup, And one-time initialization is pin mode. Which pin you want to configure as a input or output, you mention that. In today's session it is input. Then the void loop, you do whatever you want reading the pin, right? So that's a traditional way of mentioning. If you want more details about what do you mean by pull up resistor, you can refer the manual where it is mentioned, right? If you carefully read the properties, particularly the input pull up resistor, based on the controller which you are using. For example, from ATML you have ATMEGA series, where pull up means 20 kilo ohms of resistor which is connected to VCC. Maybe some other controllers, it could be 50 kilo ohms, it could be 150 kilo ohms, whatever. So what does it mean? It means the amount of current flowing through that pin is a choice which you have to select by using this pin mode input pull up. All right. The another thing is about the configuration. So whenever you configure the pin, right, whether it is a output or input, by default, every pin has some current it can source or sink, irrespective of the pull-up resistor. Even if you don't use the pull-up resistor, it will source or sink. Generally speaking, ATMEGA controllers has the ability to provide, means source, or sink, means negative current, up to 40 milliamperes. So 40 milliamperes is the current in any microcontroller pin as far as ATMEGA is concerned, but maybe controller to controller it will differ. Let us assume somewhere around 16 milliamperes is a standard practice for syncing, 10 milliamperes, 40 milliamperes. However, if you want to interface, let's say some relays, solenoid valves, motors, then 40 milliamperes is not sufficient. It may be beyond. At least a read relay also takes more than 100 milliamperes of current. So you require external driver pins. So do not make the pins to dead, because if you draw more current, then inside the controller, the output stage of the pin will be permanently damaged. It may become dead. However, the controller may still work. Possibility is there because other circuit is not damaged. But certain pins are going to be damaged if you draw more than the specified current. So please remember specifically about you when you interface any output devices or input devices, you are not supposed to draw more than the rated sourcing or sinking current. All right. So in today's session, specifically we are talking about the input configuration. So there are two possibilities of connecting the input device. Let's say switch is a input device where you can see the switch. How will you connect the switch? One pin of the switch, you will connect it to the microcontroller pin. Microcontroller pin means any of these GPIO pins, right? One pin, you can connect any of these orange colored pins. Then other side of the switch, where will you connect? There are two possibilities. Either you will connect it to positive supply, or you will connect the other side of the switch to the negative supply, means ground. So if you connect the switch to the one end is connected to microcontroller, other end is connected to positive supply, then how the current will flow? Naturally, the current will flow from positive to negative, right? That means the current direction is from the positive source to the negative source. So that means it is sinking, means the current is flowing through the controller to the ground. So the current direction is like this. That is syncing. However, if you connect the switch, which is an input device like a sensor, switch is also a sensor which is detecting whether it is open or closed, right? Like in doors, right? We use generally in refrigerators, right? Or maybe CD players, music players, or door opening, closing in public places, and so on, or even printers or two-wheelers, four-wheelers. At several places, we use these switches or to detect whether the door is open or closed. Even in robotics also, like a touch sensor we use for any obstacle. If the robot hits, then it will come to know it's a open or closed. The switch is pressed or released. So in the second configuration, if the switch is closed, what will happen? The other end of the switch is connected to ground. So naturally, the current will flow only when this pin is connected to VCC internally. Then the current direction is from the microcontroller to the ground. So that means it is sourcing. So you need to understand the direction of the current, either two possibilities, either it is in sinking form or sourcing form. In either case, the CPU, the controller, has the ability to limit somewhere around few milliamperes of current. Let's say somewhere around 10 to 40 milliamperes of current. Beyond that, you are not supposed to draw, otherwise it will physically damage. So the best practice is that connect a series resistor always between this pin and the switch or any sensor. If you connect a series resistor, roughly let's say 330 ohms resistor, if you connect it, then assuming that if the controller, right, say for example this is 3.3 volt supply, and if the controller reads this pin, that means the current is sinking. So 3.3 volts divided by 330 ohms will roughly give you few milliamperes of current, around 10 milliamperes of current, so that the pin will never ever get damaged. So whenever you connect any sensors, any switches, or even in case of output also, make sure there is a series resistor which will limit the current to somewhere around 10 to 40 milliamperes of current. However, the rule is not same if the voltage is not 3.3 volts. Let's say if the V is increasing, let's say you make it 5 volts, you make it 10 volts, you make it 50 volts, 100 volts, 500 volts, 1000 volts, 1500 volts, you can apply absolutely no problem. VCC could be anything, but the pin will be damaged only not because of the VCC. The pin is damaged because of the current. So please understand, in electronics, load means not voltage. Load means current. The amount of current will flow. Alright, so as the VCC increase, also increase the resistor value so that the current remains same. So this is the precaution you should take it. Alright, so with this brief introduction, now let's interface various sensors to the microcontroller pins. Any pin, it could be pin number 2, 3, 4, 5, 6 up to 13 on the left hand side, or pin number 18 to 30 on the right hand side. Any pin you can use it for interfacing the sensors. However, please note they have multiple functions. The same pin, for example, you can see the green means the same pin can also behave like a to D converter, that we will see in the next session. Or the same pin also has the ability as a RTC pin, or you can see in the pink it also can behave like a touch sensor, or some D to A converter, right? This has the ability to generate the waveforms, analog waveforms. So two DAC channels are there, nothing but D5025, D26. Also right, these pins have serial ports, right? You can see types of serial communications: MISO, MOSI, CLK, right? This light blue color, and chip select signal. So these are called SPI ports, right? Serial peripheral interface. But it is also having another SPI port. You can see here another gray colored one, MOSI, MISO, clock, chip select. So you have two SPI ports, and also I2C bus. You can see the uh, violet color SDA and SCL. This is called I2C. I2C means two wire serial communication, where clock is available on pin number 29 and data pin is available on pin number 26. Plus, it also has the ability to communicate through UART, that is Universal Asynchronous Receiver Transmitter. You can see this sky blue color TXD0 RXT0, right? So this is COM port 2728. There's another COM port UART 21 and 22. So two UART serial communications, one I2C communication SCL SDA, and two SPI communication. One is here, another is here, right? And other peripherals like touch sensor, D2A converter, real-time clock, A to D converter, GPIOs. So these many plus PWM, wherever the tilde is given, they are also used for generation of the pulse width modulated signal. So I hope now you can understand the same pin can behave multiple ways. In the previous session, we have used as a output port. In today's session, the GPIO pins, all the GPIO, every pin is a GPIO for that matter. We will see how to use them. That means out of 30 pins, if you neglect these supply and ground and enable means reset. So 2 plus 2, 4 plus 1, 5. So out of 30, 25 pins are could be general purpose input output lines. So you can use 25 inputs, 25 sensors. You can connect it to this ESP-32 30 pin IC. Right. So now we will use various sensors to interface and to program it. What are the sensors we have? We can connect at least on the board, where we will see, for example, we can interface sensors like digital sensors or sensors like analog sensors. However, analog sensors, we cannot connect it on the GPIO pins. We'll have to connect only wherever this green color pins are there. That is the ADC pins. Analog means analog to digital. Let us revisit our board, how it is designed, specifically in the context of sensors and its interfacing. If you look at the placement of the components, you will notice there are some sensors, if you carefully read, like infrared LF1, infrared LF2, infrared LF3. Similarly, infrared MR, infrared ML, infrared B. So these are the sensors which we have connected to the multiplexer. If you remember, when I explained in the first session hardware description, this multiplexer, right, X0, X1, X2, X3, X4, X5, X6, X7. X7 anyhow is connected to potentiometer. These 7 inputs are coming from these infrared sensors. You can connect any sensor, any 3 pin or 4 pin sensor in these female budge connectors. If you carefully look at the pin diagram, pin number 1 represents the supply, Pin number 2 represents the ground. Pin number 3 represents the input signal, and the input signals are X0, X1, X2, X3, X4, X5, X6. So total 7 sensors you can connect in these slots, you can insert into these slots. It is your choice, though I named as a IR sensors, but it's your choice. But however, they could be analog or they could be digital, because digital also can read, and sorry, analog also can read digital sensors. So since there is an analog multiplexer as explained in the first session, total 8 in. Similarly, if you look at the other possible inputs other than these 7 analog sensors, you can interface other pins like 4 pin, 5 pin, 3 pin slots are provided. You can connect any sensors because basically they're all connected to your either analog channels or digital channels. Some of them, wherever X is written, X1, X0, X1, X2, X3, X4, X5, X6, wherever X is written, that means they are connected through multiplexer. What in by through multiplexer? That means these analog signals are not directly connected to the microcontroller, right? They are connected to the multiplexer first. Then the output of the multiplexer is connected to AOP1. What is AOPP1? AOP1 means that is the first pin number, the second pin, right? Second pin of the microcontroller. So second pin of the microcontroller is nothing but this one, GPIO 36, second pin. So as good as ADC channel number 0, right? You can see 0, 3, 6, 7, 4, 5. So these are all the ADC channels. So second pin of that is GPIO 36 is connected to the analog multiplexer. So 8, we have used 8 channel analog multiplexer. The output of the analog multiplexer is connected to the second pin of the microcontroller, that is IO 36. So when you write the program, you try to read the second pin of the controller. If at all you are interested, these 8 analog inputs. Alright, so that is the significance of the pins when you interface any of the sensors. So look at the name mentioned here. Like if you see, for example, generally pressure sensor is a 4-pin connector. First pin is 3.3 volts, second is ground, third is connected to DAC IP1, DAC IP2. That means naturally you should configure those pins of these two pins, DAC IP1, DAC IP2 means, if you see DAP IP1, DAC IP2 is nothing but this GIPIO 25, GPIO 26 are connected to the pressure sensors. So like that, ADXL is connected to analog multiplexer because we have mentioned X4, X3, X2. Sound is also connected to analog multiplexer X1. Servo motor is, of course, this is not a sensor, it is output. Touch sensor is directly connected to IO pin. DHT sensor is directly connected to IO 19th pin. Vibration sensor is connected to IO 23 pin. Ultrasonic sensor is again connected to DAC IP1 and IP2. Means either you connect ultrasonic sensor or pressure sensor, not both, because you have shared the same pins. Similarly, sharp sensor is connected to X5. That means if you are using X5, then do not mount any sensor on this slot, X5 slot, because both of them will contradict. So any one of the sensor you should use it. Alright, so these are the possibilities of the slots which are available on the board, right? If you carefully look at the board, your pin diagram, right? As I mentioned, like say DHT11, you can see these 3-pin slot is available. Vibration sensor, this 3-pin slot is available. And similarly, you have the touch sensor, 3-pin slot is available. optocoupler is directly IC is inserted here. Temperature sensor is directly connected into this slot. Hall effect sensor is directly connected to this slot. Sound sensor, there is a 3-pin slot is provided. Sharp sensor, 3-pin slot is provided. Ultrasonic sensor, 4-pin slot is provided. Otherwise, you have the infrared sensors like I already mentioned. IRF1 here, IRF LF3, LF2, LF1. On the back side of the PCB, IRB, IRM, then IRML. So these are also sensors where you can connect. However, the moment when you say IR, we actually used a multiplexer. So CD4051, this is the digital IC which is taking care of converting, means selecting any one of these IR sensors into output, which is connected to the in the microcontroller pin number 2, that is IO36. Okay, so quickly, instead of soldering all these sensors, just DHT11 sensor, let's even don't use the sensor, we will use this DHT slot as a switch, right? So if you carefully look at the connectors in DHT11, out of these 3 pins, if you carefully look at, center pin is input pin, right? IO19, GPIO19. Pin number 1 is 3.3 volts, pin number 3 is ground. What we do is take a jumper, a simple 2-pin jumper, short circuit this IO pin, IO19 pin, this side. That means short circuit pin number 1 and 2. So what will happen? Your microcontroller will receive 3.3 volts on IO19 and try to read that pin and display it on some LED or some serial port. LED is very simple. Read IO19th pin and the same value you try to output on where the LEDs are connected. Either you have a inbuilt LED, if you remember we have written a first program about the built-in LED, or you can use any of these 4 LEDs where we have connected M1, M2, M3, M4 are nothing but you have we have designated M1 means these pins M1, M2, M3, M4 which are connected to microcontrollers pins. So microcontroller pins means alright. So microcontroller pins means GPIO27 M1. Simply read the IO19th pin where we have provided a 3-pin slot, that is IO19 on DHT11, and display it on either an IO27 or other pins of the LEDs. Or as if you remember graph plot in data types, we said dump the data on the serial terminal so that you can watch the variable on the serial terminal of the Arduino compiler. So let's see that program IO19, how will you configure it using the compiler. So you can define the pin, right? Let's say you are interested not the other pins, otherwise as you say, if I said 18, 34, 23, 32, 19, they're all the pins where we have connected the sensors. But now let's use this 19th pin, this pin, and configure this pin as a input mode. Now you see we have made this pin as an input. That means the data will come from outside world to the inside the microcontroller. Where which pin we have mentioned, pin number 19. That's in the void setup because the code will be executed only once. Then in the void loop, what we are saying, configure the serial port because we want to dump the screen through serial port with a baud rate of 9600 bits per second, so that with the same rate the data will be transferred from the microcontroller to the other system like computer, and that is the configuration. Then serial print, that means read the data. Which data? This data, right? Digital read. Okay, now you see the digital read means we are trying to read this pin. Which pin? Pin number 19, and dump it. Okay, dump it on the serial terminal, because serial print ln and delay. So in this loop we'll keep on reading this pin number 19 and display it on the computer monitor. This is one way of reading the data from the pin and display it on the computer monitor. Or, because see, anyhow microcontroller has a serial port to dump the data. Or if you do not want to use the serial port, let's say you comment this. Okay, just to begin with, you want to show this data on the LED. So that means now where is your data is available? Your data is, you have said this pin is input. So similarly, if you want to use the LED, okay, what you do is pin mode. Okay, which pin? Some other pin, right? Let's say this is pin of input, and this is pin of, let's say, output, right? So output pin you want to configure as a output. Now you define, right, this pin you want to configure as a input. Okay, then some other pin you want to configure as a output. Okay, so which pin you want to configure? Pin number 24. Okay, so pin number 19 is your input, pin number 24 is output. That's what you see we have configured pin mode. One is input, other is output. Why 24? The reason is, if you remember, where the LEDs we have connected on the board. So the LEDs are connected, see, sorry, not 24, 27. So 27, 14, 12 and 13. So let's say your ILO 27. So this is output. So this both, one is input, other is output. Now what you want to do in the loop is that you want to write the data of this pin on the output side. Alright, so now if you write digital write, which pin you want to write? To this pin, right? Where we have configured as a output pin, that is pin number 27. So that pin, output pin, from where you want to get that value, you read this pin, and the same pin you try to write it here. So whatever you are reading, you are writing. You are reading from pin number 19, writing to pin number 27. So whatever you get it on pin number 19, as it is you are passing to pin number 27. So in this program, no need of using serial port to verify your sensor data, assuming your sensor data is digital data. Whatever is the data, you get it on the specific pin, as it is you are passing to the outside world on some other pin where you have connected LED. So no need of any multimeter, CRO, serial communication. You read it, you write it to the output where LED is connected. Let's verify that. So this will simplify, and as I mentioned, no need of having a sensor also, because on the board where we have provided this connector, right, DHT11 connector, where one side you have VCC, other side you have ground. So you just short circuit pin number 2 and 1 if you want to give high voltage, or if you want to give 0 volts, short circuit pin number IO19 to ground. We cannot do this with other pins because the center pin is input. and the left hand side and right hand side is the VCC and ground. So it is easy to use a jumper, 2-pin jumper. If you are having a female to female or male to male connector, then probably you can use like IO23, IO18, or this DAC input, DAC output pins also. That carefully you have to either give VCC or ground looking at the pin configuration. You should try this either using digital read, digital write syntax for reading the pins, or use the digital read. However, whatever I have commented, this serial begin, initialize the serial port, serial print. If you remember, we have used this program in the data types or by writing the mathematical models, and dump this data on the computer terminal. Then it will display either 0 or 1. All right. So in the next session, we will discuss some, instead of digital, we'll try to use, instead of switch, we will try to use some sensors. We'll see types of sensors which we have already provided on the board. Some of the sensors are already there. Particularly if you see the sensors, we should try these, some of the sensors. We will see which sensors which we have on the board. So those sensors, one after another, you can insert it and try yourself for writing the programs. And then subsequent session, we will try analog sensors also. The difference is when you use the analog sensors, then you won't be using GPIO pins. You have to use the ADC pins, and it's not a digital read. It has to be analog read. And analog read and mention which pin of the analog, these green colored pins, you want to read it. And A to D converter is having a resolution, right? Based on the resolution, let's say D0 to D11, 12-bit resolution means 2 to the power of 12, where your output voltage could range anywhere between 0 to 4096. So we will see, I mean, how ADC works. It's altogether a different peripheral. GPIO is the simplest peripheral, as we have seen, like LED. Similarly, in input also, it is very easy to configure and understand. But however, ADC, you need to understand the sampling, amplitude, and other issues related to the percentage of error in the quantization, linearity, and so on. So there are some other issues we need to understand. All right.